Hello. In this session, we shall discuss about column chromatography, specifically liquid, solid, adsorption chromatography. As the name indicates, the chromatographic technique is based on the mechanism of adsorption. Main function of the column is to support the stationary phase. It is often a long cylinder made up of glass with a stopcock at its lower end. The stationary phase is finely divided adsorbent like silica, alumina, calcium carbonate, cellulose, etc. The mobile phase may be a solvent like petroleum ether, acetone, benzene, water, methanol, etc. Sometimes mixtures may also be used. In column chromatography, the mixture to be separated is introduced at the top of the column, followed by addition of mobile phase. As different components percolate through the column, they are adsorbed onto the stationary phase to different extent. The process of desorption occurs when column is irrigated with a solvent. As a result, the components which are held loosely travel faster down a column than those adsorbed strongly. This results in separation of the component mixture into bands, and the process is called development of a chromatogram. As we can see in this image, if a mixture of three components A, B and C are added to the top, then at the beginning the mixture is unresolved. As time passes, different components can be separated from one another to form distinct bands that come out of the column at different time. Components are washed down one by one in increasing order of adsorbability and collected in separate fractions. Weakly adsorbed components emerge first. Strongly adsorbed components emerge last. The solvent is also called as an eluent, and the process of dissolving out components from adsorbent using a suitable solvent is called elution. An example is the separation of ortho and para-nitroaniline from its mixture. The solid phase is alumina and the liquid phase, that is solvent, is benzene. As ortho-nitroaniline is less strongly adsorbed than its para component, it elutes first. Adsorption column chromatography finds application in a variety of fields. For example, it can be used for separation of two or more organic compounds which are otherwise difficult to separate. It can also be used for purification of organic substances by removing impurities. Solutes can also be concentrated from dilute solution by this method. One of its important application is in identifying, separating and purifying natural products. It also finds application in a variety of industries for product identification. Thank you for listening. If you have any doubts, please contact me. Thank you once again.